Okay, hi everybody. So here's some hints for homework 4. So for number 1, this equation is just one equation where the left side is a complex number and the right side is a complex number. This equation is 4 equations of complex numbers, 1 equation of 2 by 2 matrices. What do I mean? Well, if we look at when are 2 matrices equal? Well, when every entry is equal. So let's look at this entry, and we'll get one equation. If we multiply these matrices, we get a matrix whose top left entry has to be equal to 1. That's one equation. Then the top right entry, whatever it is, has to be equal to 0. That's a second equation. In that case, for this second entry, we get a c bar plus b d bar. And so if this equal sign is true, then it has to equal 0. So there's another equation. So we have 1, 2, 3, 4, 5 equations. And there are 4 complex variables. Each of these is a complex number. Right? So we have 5 equations and 4 variables, and the problem asks you to show that the conditions, those 5 equations, allow you to equivalently describe the set of matrices here instead by only 2 variables. See how we've gotten rid of C and D, and 1 real equation. Okay? So, of course, you can view this equation as a complex number equation, but this is a real number, this is a real number, so the left side is a real number, and the right side is also a real number. So we have 1 real equation and 2 complex variables. Remaining. So we don't need 4 complex variables, we only need 2. And your task is to show how the 5 equations in 4 variables can be solved and substituted into one another, and eventually show that you only need 2 variables if you replace C by negative b bar and D becomes a bar. That will now give you only 2 variables, A and B, and 1 equation. Okay, so explain to me how this works. Equivalently described. All right, next. So on problem 2, you can start on problem 2 without solving problem 1, provided you take the result of problem 1 and use it for problem 2. And so this one's actually pretty easy when you think about it. 2 complex variables is basically R4. 1 real equation should somehow, you have to explain, give a 3-dimensional unit sphere. Next. Okay, so this one, we make a definition right here of a certain formula that we call chi sub m. Chi sub m. It's much easier to just make m equal to 3 and see what it looks like. Make m equals to 2, see what it looks like. And then your problem is to explain why this thing that's defined up here is also equal to this fraction. Okay, so my advice is to first do it for m equals 2. Show that this thing is equal to e to the I for theta minus e to the minus I for theta over e to the I theta minus e to the minus I theta. In other words, set m equals to 2, and these 4s should be 3s, I'm sorry. M equals 2, so m plus 1 is 3. Problem 4, what I would like you to think about for problem 4 is once you have shown this, you will use it to show this. And all you need to do is think about this picture. Here's a complex number z. Here's the complex number z bar. Here's the complex number minus z bar. And then here is a parallelogram.